In this video, we're going to be talking about infinite series, which means that we're going to be adding up an infinite number of terms and coming up with a single number as our solution. Now, that may seem impossible, and for most series it is. For example, for an arithmetic series, we can't ever have an infinite arithmetic series that adds up to a specific number, because we're just going to be adding the same amount each time. So the number is just going, or sum is just going to keep getting bigger and bigger. It's going to go off to infinity. Or if we're adding a negative number each time, it's going to keep getting smaller and smaller. It's going to go to negative infinity. And for most geometric series, so up here we have the sum. This is the sum that we talked about before of a finite geometric series. And you can see that if r is bigger than 1, then the numbers that we're adding each time are just going to keep getting bigger and bigger. And so our series is just going to go off to infinity or down to negative infinity. And we're never going to come up with a single number. However, if r is less than 1, let's think about what happens to this r to the nth power if r is less than 1. Let's say r is 1/2. So 1/2 to the second power is 1/4. 1/2 to the third power is 1/8. If our numbers get bigger, 1/2 to the 8th power is 1/256. 1/2 to the 16th power is 1/65,536. So you can see that as this n gets bigger, and we're only to 16 now, we're going off to infinity, but already at 16, we're at this really tiny number, 1/65,536. So you can see that as this number, if r is less than 1, and we're going to infinity with our n, then this r to the nth power is going to go to 0. And so the sum of our infinite series is going to be, well, this is now just 1 minus 0. So a sub 1 times 1 is a sub 1 over 1 minus r. So there's our formula for the sum of an infinite geometric series. But as I said before, this only works if r is less than 1. And actually, if if the absolute value of r is less than 1. In other words, if r is between -1 and 1. So if it's on that interval, if r is anywhere between -1 and 1, then this is going to work. This is going to give us the sum of that infinite series. However, if r is outside of that interval, then there is no sum. It's just going to go to infinity or to negative infinity, and we really don't care. All right, so let's do an example of, let's say we've got 1/2 plus 1/4 plus 1/8 plus on to infinity. So here, the sum is going to be equal to the first term, which is 1/2, over 1 minus the common ratio, which you can see that to get from 1/2 to 1/4, you multiply by 1/2, and then multiply by 1/2 again to get to 1/8. So this common ratio is 1/2. And 1 minus 1/2 is 1/2, and 1/2 divided by 1/2 is 1. So this sum is 1. So what we're saying is that if you add up all these terms and just keep going to infinity, you're going to get to 1. Or at infinity, it's equal to 1. What's really happening here is that we're getting closer and closer to 1 without ever getting there. 1/2 plus 1/4 is 3/4, plus 1/8 is 7/8, plus 1/16 would be 15/16, plus 1/32 would be 31/32. You can see that we're getting closer and closer to 1. It's getting bigger every time, and it will keep getting bigger forever, but it's never going to get to 1. It's just going to keep getting closer and closer to 1. So we say that the sum of that infinite series is 1. All right, let's do a couple more examples here. So the first example, we've got negative 4/5 plus negative 4/5 squared plus negative 4/5 to the third plus and on to infinity. So the first thing we need to determine is this going to work? Is our r between -1 and 1? And we can see that yes, it is. Negative 4/5 is greater than -1, but less than 1. So so this is going to work, and our sum is going to be equal to the first term, which is negative 4/5 divided by 1 minus the common ratio, which we can see here is negative 4/5. So this is going to be 1 plus 4/5. All right, so negative 4/5 divided by 1 plus 4/5. 1 plus 4/5 is 9/5. So negative 4/5 divided by 9/5 is the same as negative 4/5 times 5/9. Remember that dividing is the same as multiplying by the reciprocal. And then these 5s here are going to cancel, and we're left with negative 4/9. So there's our answer to our first example, negative 4/9. So if we added up all these terms to infinity, we're going to end up with a sum of negative 4/9. All right. The second example uses sigma notation. We want the sum from k equals 1 to infinity of negative 5 to the kth power. All right, so again, the first thing we want to do is check whether or not this is even going to work. Remember that r has got to be between -1 and 1. And here the r, the common ratio, is -5. That's outside of this interval, so this is not going to work. And so our answer is just going to be no sum. And that's going to be our answer for example 2.